Hello students, welcome back. Previously we went through quadratic formula method and then we went through the factorization technique for monic quadratic equations. Monic came from mono, which means one in Latin, and the leading coefficient is 1. The leading coefficient is 1. Here too, the leading coefficient is 1. Here, leading coefficient may look like 3, but after simplification, it came down to 1. So those are all monic quadratic equations. Now let's study some non-monic examples, like these. The quadratic coefficient is 3. Here, the leading coefficient is 10. This one, hard to tell, but it'll become clearer once I break up all those parentheses. How do we work out this kind of problem? It's non-monic. In this case, there are a lot of different ways to factor. And if you ask 5 different mathematicians, you may end up with 5 different methods. If you ask 50 different mathematicians, you may end up with about 10 different methods, maybe even 15 different methods. Which one is the best? There's no best, there's no worst. If it works for you, that's the best for you. If you're making a lot of mistakes with that particular method, it's not good for you. So, learning multiple methods is not something I'd like to advise. For example, my son does it completely different way than I do. He learned it from his teacher, and then he's doing fine, so I'm not touching it. Hey, you just stick to whatever you're doing it right. And same goes with you. I'm going to teach you a certain method here, which I'm going to call tic-tac-toe method. And if you look up tic-tac-toe method of quadratic equation in YouTube, you can find many videos there, maybe 100 videos there, but among them, there's some versions, there are different versions of tic-tac-toe methods as well, so it's really diverse. So let me emphasize again, if you already have a scheme and that works for you, stick to it. Now, if you are unsure, or if you're learning, or if you're making a lot of mistakes in your method, then pay attention to this. I'll just tell you a new method which is working for me. How does it work? Let's begin with a tic-tac-toe board. And then let's begin with the leading coefficient, the first coefficient, and the constant term, the third coefficient. So 3 times 2 is 6. That is my step 1. Okay, that's my step 1. Next, factors of 6 adding up to -5. This is positive 6, so we have to have two same signs. So negative times negative adding up to -5. What do you get? -2 times -3. Did everybody get that? That's my step 2. Alright? So I got this one involved in step 2. I got first and last involved in step 1. Now let's go to step 3. Let's fill up this puzzle. And everything here, horizontally, vertically, they're all multiplications. And the first column is always all positive as long as the leading coefficient is positive. So how do you fill up? Well, 1 times 3 and 3 times 1, 1 times 2, and where do I put negatives? Here and here. Did I do this right? Please check. Horizontally and vertically, all multiplication. 3 times -1 is -3. 1 times -2 is -2. Vertically, 3 times 1 is 3. Negative 1 times negative 2 is positive 2. Everything fits. Now let's go ahead with cross multiplication. 1 negative 1 this way and 3 negative 2 the other way. So one direction here and the other direction like that. Cross multiply. So 1 negative 1, 1x minus 1, and then 3x minus 2. Nobody writes like this. Instead of 1x, we just write x minus 1. In any case, we got the factorization done, and we are ready to answer the problem. From the first factor, which I just highlighted in purple, what do I get? X minus 1 is equal to 0, therefore x is 1. Purple. And then the second factor, which I'm highlighting in green, 3x minus 2 is equal to 0, so 3x is equal to 2, therefore x is 2/3. Did I do this right? So we have these two solutions. X is either 1 or 2/3. From this factorization, this constant term is the numerator and denominator is the coefficient. 1 over 1, and we have sign change. 2 over 3, and this is negative, so we have sign change, so we have positive 2/3. Let's see, do we have answer key here? Yeah, 1 or 2/3. But let's keep this tic-tac-toe as a reference. Okay, let's do it one more time. So 10y squared plus 7y minus 12 equals to 0. That's the problem, isn't it? And then for this problem, let's set up this tic-tac-toe board. Oop, what did I do? I don't know, I just accidentally clicked a wrong key. Sorry about that, I got it back. Okay, in this tic-tac-toe board, first 10, and then negative 12, and then we get negative 120. So first number 10 times the third number negative 12, so we get negative 120. Agree with the setup? Okay, that's the starting point. Next, factors negative 120 adding up to positive 7. Good luck. Negative 120, so we have to have two opposite signs. And then they're adding up to positive 7, so bigger number part will be positive. Let's see, 1 times 120, that never works. 2 times 60, no. 3 times 40, and so on and so forth. And try until you hit something. Stop the playback and find out what you get. If you do it right, you're going to get negative 8 times positive 15. 15 times 8 is 120, and that difference is 7. And we want positive 7, so positive 15 and negative 8. And that's how this last column is set up. Alright, okay. So from here, let's go to the next step. Let's fill out these boxes. Horizontally, vertically, they're all multiplications. So what do you get? 5 does not 5 does not divide -8, so 5 should be down here. So it should be 2 times 5 like this, and 5 times 3, and 2 times 4, and this should be negative. Carefully check. Horizontally, vertically, all multiplication, and the first column should be all positive. And then what do you get? Crisscross, cross multiply, you get 2y plus 3, and then 5y minus 4 equals to 0. See that? So 2, 3, and then 5, -4, like that. So that's how you got 2y plus 3 and 5y minus 4. From the first factor, what do you get? 2y plus 3 is equal to 0. 2y equals to -3. Y is -3/2. You see, the numerator over the denominator, but we have sign change, -3/2. 5y minus 4 equal to 0. 5y is 4. Y is therefore 4/5. 4 over 5, 4/5, but we have sign change. This is negative, so we have positive. So this kind of factorization method is called tic-tac-toe method for quadratic equations. And if you look up to YouTube, then you'll be able to find 24 of those. And please beware, there are some variations of those. There are several versions of the same tic-tac-toe method, so they can be a little bit confusing. As a matter of fact, this entire technique on non-monic quadratic equation method is very confusing to a lot of people, because there are so many different ways to get the same answer, and many people do not understand that they do not have to learn all those different methods. All you need is just one method that works for you. And if everybody had been new, then I would just give you one method and then just mold everybody into that. But that's something you can do in middle school and high school. In college, I can't do that. A majority of the students already have their favorite methods, so I do not want to touch that. And this lesson and this method I told you about was intended only for the student who want to learn a new method, because the old method does not really work for you, and you end up making a lot of mistakes from that. So that, you know what about some other method? Well, you happen to stumble upon to me, so I'm just telling you this method. If you go to some other instructor's math class, you'll probably end up learning some different method from him or her. Okay, alright, so much for non-monic trinomials. We have some more examples to do, but mostly done. And one more example as an optional video, and then we're going to move on to section 3. That's my plan.